Hello, my dear children. Welcome back to Sudarshana Madam's class. And today we have a maths activity for you, and our topic for the day is area. Now, what do we understand by the term area in geometry? In geometry, area can be defined as the amount of space occupied by a two-dimensional figure. And remember, area is always measured in square units such as square centimeter, square meter, square feet, square kilometer, and so on. Why is it always measured in square units? Well, this is so because it is a two-dimensional shape that we are dealing with. Here, the two dimensions that we have are length and height only. So, we are always expressing the unit of area in squares. I think now it is quite clear why we use the square after writing the area of any figure. Isn't it so, children? Okay, let's continue. Well, for those who are just wondering, what does a two-dimensional shape mean? Here, let us see. A two-dimensional shape or figure is a flat, plain shape that has two dimensions, that is length and width, as we read a little while ago. For your information, these 2D shapes do not have any thickness and can be measured in only two faces: a circle, triangle, square, rectangle, etc. are two-dimensional shapes. Now coming to the area of a rectangle, we have a very simple formula for finding out the area of a rectangle. That is, if we multiply the length of the figure with its breadth, then we can find out the area of a rectangle. In the same way, if we want to find the area of a square, we can multiply its side with side. Actually, here also the concept is same. We can multiply the length and the breadth to get the area of a square, but because a square has the same dimension of length in all sides, that is, all the sides are same in length, therefore we consider them as sides and not as length and breadth, because length would mean it is longer, isn't it? So that's why the sides are considered to be there for square, and if we multiply one side with the other, we get the area of a square. So what to remember? Area of a rectangle is length into breadth, and that of a square is side into side. Now it's time, dear children, to prove that the area of a rectangle is length into breadth, and it is actually so with the help of an activity. So here we go. As you can see, dear children, here I've cut out shapes, or you can say units, of the same size and shape, 15 in number, from a cardboard. Okay, and how many have I placed side by side to make its length? Let's see. I've got 1, 2, 3, 4, 5 such units along the length. And how many along the breadth? 1, 2, and 3. So, I have cut out the congruent squares having the same size and shape on a cardboard. I've cut them out with the help of my scissors, and I have placed them, arranged them side by side on a sheet of paper, in 3 rows and 5 in a column of 3, and in the row having 5 units. Okay, so you get a rectangle when you arrange them. Now let us have a closer look at the rectangle on the sheet of paper, which I have arranged with the help of this cutout cardboard units. So let us begin. Now see children, have a closer look at this rectangle which is named as A, B, C, D. Okay, this rectangle A, B, C, D has got 15 squares, and these are placed in 3 rows and in 5 columns, as you can see in this figure A, B, C, D. So, along the length, how many squares do I have? 1, 2, 3, 4, 5. And along the breadth, I have 1, 2, 3. So, I've arranged them in 1, 2, 3, 4, 5 columns, and I've arranged them in 1, 2, 3 rows. Okay, now let's see and count how many squares are there over here. I've got 1 here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. That means when I count the number of squares, it comes out to be 15 square units that I have got over here. Now let us apply the formula of length into breadth that I have shown you before. Area of a rectangle is length into breadth. Now let us apply this formula over here. Now let us see the length 1, 2, 3, 4, 5. So it is 5 squares I have. And what is the breadth? 1, 2, 3. So I have how many squares in the length? 5. How many squares in the breadth? 3. Now the total number of squares, that is the total area according to the formula, should be length into breadth. So let us go for 5 into 3. 5 3s are 15. Here you're correct. It is 15 that we are coming out with. So 15 is equal to length into breadth. If we get 15 as the answer after multiplying 5 with 3, then it is the same over here what I have placed the blocks, or what if you call it the squares, after placing them side by side. I also get, when I count, I get up to 15 squares, isn't it? If the side of each square is 1 centimeter, we say that the area of the square is 1 centimeter square. Okay, if this is 1 centimeter and 1 centimeter on all sides, 2 sides, then I would say area will be 1 centimeter square or 1 square centimeter. Okay, now the area of the rectangle ABCD then will be 1 square centimeter, 1 square centimeter. If you count like that, it will come to 15 square centimeters, isn't it? So this verifies a formula of the area of a rectangle. Length into breadth, 15 square centimeter. And if I consider this as 1 centimeter and 1 centimeter, so the area of this particular unit is 1 square centimeter, then the area of 15 square units, because there are 15 total squares here, so 15 units will be 15 square centimeter. So that helps me to arrive at the final observation that the area of a rectangle is equal to length and into breadth. If we multiply length and breadth, we will get the area of a rectangle. Okay children, now if it is a regular rectangle, we can find out with the formula of length into breadth. Now that we know that it is a correct calculation with the help of the activity, that we can find out the area with the help of multiplication of its length and breadth. That is okay for the regular rectangle. But what if the figure is somewhat like this? How can we find the area? Then we use the grid, and then we use the counting system to get the area of these figures. Sometimes we can also do in this method, we can just divide this figure into two parts. Maybe we can cut it from here, make it one rectangle here and another rectangle here, and find the areas of these two rectangles separately and then combine, that is add them to get the total area. Okay. Or else there are other methods in which we can go about it. Okay. So that is by counting the number of squares in the grid. So if we have full squares, the area covering full squares, then what we can do is we can just count the number of squares it is occupying, like 1 square, 2, 3, 4, 5 and 6. So this is occupying 6 square centimeter. If each length is 1 centimeter and 1 centimeter, and the area of this a single unit is 1 square centimeter, then area of 6 square units will be 6 centimeter square. Okay, 1 unit is 1 square centimeter, so area of 6 units will be 6 square centimeter. Okay, now let us come to this figure. Let us first count the full squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, but we can see some half squares here. This one is occupying half the area and this one is occupying another half. So this is half and half. Okay, so together two halves will make one full. So together if I take this, so it will come to 11 squares. So the area occupied this figure will be equal to 11 square centimeter. If I consider 1 unit as the area of 1 unit as 1 square centimeter, then the area of 11 units will be 11 square centimeter. Okay, so if we have a figure like this is also very easy to calculate. These are all occupying full boxes, so units. So 1, 2, 3, 4, 5, 6, 7, 8 and 9. So we have got, if 1 unit is occupying 1 square centimeter area, then 9 units will occupy 9 square centimeter area. Okay, now this is a little bit challenging because we've got some half squares and smaller areas filled up by the figure. So let's see what we can do for this. Let's first count the full squares. Okay, this is one full square, this is another, this is third, fourth, fifth and 6 full squares. Okay, now let us count those squares which are occupying more than half. Okay, we can consider them as full squares. So this is occupying more than half. I can take it as 7 square. This I can take it as the 8 square. This is occupying too little a space. We will not take this into consideration. We will take this one which is more than half. The area covered is more than half of this unit that is represented here in the grid. Then we will take it as a full square. Okay, this also we will consider as a full square. So here comes a 10th square. This is the 11 and this is the 12th one. Now after this, let's see, this we will ignore, this we will ignore, this we will ignore and this we will ignore. Now see, at the top we've got half square and half square. So this together, after the 12 square, this together will form the 13th one. Okay, together. Half and half. Half plus half will give you 1. Right, so we've got here 13 square centimeter. If I consider 1 square as equal to the area of one unit as 1 square centimeter, then the area of 13 units which I have counted here with full squares and half squares and more than half squares, then the full area of 13 units will be 13 square centimeter. I hope now it is clear to you. Now coming to this figure. This figure, let us count the full squares first. Okay. This appears to be a full square. This is another full square, and full unit is covered here also. Now these are the full ones. Complete boxes are covered, okay, with the area of the complete box is covered. Now let us see which is more than half is covered. So I can consider this as the 7th one. I can consider the 8th one. This is too much less, so I will not take this. I will ignore this. I will consider this as 9th one. I can consider this as the 10th one, as the 11th one. This is less than half. I'll ignore it. This is the 12th one, and this is the 13th one. And I'll ignore this. And I'll take this also as the 14th one because it is more than half. So I've got 14 units here. Now if the area of one unit is 1 square centimeter, then the area of 14 units will be 14 square centimeter. I hope now it is clear to you how to count the irregular figures. But first you have to use a squared paper like this on which you can place it, and then you can tick out the area. Okay, so I think that was enough of area. More on some other topic another day. So if you really like it, the way we've been learning the topics, please subscribe and share the video and like the video, and please join me next time I give you another video. Okay, so bye-bye for now. Take care, children. See you next time. Love you all.